All right, time to turn our attention to this board, which has all the pots and jacks and these switches on it. And just two components on here we're going to change. We'll get to that. First of all, in yesterday's video, in the comments, someone asked if I could show how to work on these boards without damaging the traces. And I've shown that in great detail in a Princeton video, which I'm linking below. I really show that in that. But the other thing that I don't really address in that is the iron that you use, the soldering iron. If I were trying to do this work with a 20-watt Weller pencil iron from the hardware store, odds are I'd be burning the hell out of things because it doesn't get hot enough, so you have to leave it on there a really long time. By the time what you want to work on gets hot enough, everything gets hot, too hot. Conversely, if I were to use my 85-watt or 80-watt chassis iron on this, everything would be smoked. You can be too hot, you can be not hot enough. I'm using a Hakko FX 951, which is a very high-end soldering iron because I do this for a living. And for this lead-free board, I'm using it at 750 Fahrenheit. For older amps with a leaded solder, I typically run about 700, 725. It makes a big difference. Before this 951, I had a 936 Hakko, which is also a very good choice, certainly more affordable for people who don't do this professionally. I think you can get them used for like 85, 90 bucks. Well worth it, and in my experience, better than the Weller temperature-controlled stations. The Hakko stuff is the way to go. Anyway, hope that helps you. But see that Princeton video for the real details. What I'm going to do here is I want to make sure that these solder joints on the input jacks aren't likely to break. And while I prefer to do this to all the pots, and this is a budgetary concern for this owner, I'm going to do the volume pots because they get turned the most, and that plays a critical role in the grid after it. If the treble pot goes out, well, that's a pain in the butt. Let's fix that. But if these go out, you can have major sound issues. So even if you're not using this channel, this pot dies. V1B can put noise into the output. So we got to have the volumes crucial. And the input jacks get mechanical stress through everyday use. So the first thing I'm going to do, wait for my iron to come back to temperature. It's got a sleep mode, so I'm learning how to use this thing. And I'm just going to apply some fresh solder to this end of each of these jacks. We'll do the ground in afterwards. We're going to do the tip first. And I'm working for you guys up here so the microphone can hear me, which is absolutely the worst place for my eyes. I can't really see what I'm doing. I would usually be bent down over the bench, squinting a lot at this point. This is a little engineer model made in Japan solder sucker. And overall, it's the best I've found. And it's not very expensive, like 30 bucks. But the Teflon tubes, the silicone tubes here, every once in a while, the solder just sticks to the inside of it, the little jagged piece, and you eject the old solder from inside, from the tube, and it just takes that bit of silicone with it. So I've got extra lengths of these. I just put a new bit on and snip it, because I have tried to fish these out of the trash can when that happens, but they are clear with predictable results. Other than that, this thing does a much better job than any of my old solder pults or the little cheap $10 ones. All right, that's the bulk of the old solder off of these. Now I'm going to go in here with the braid and get a little bit more. And again, normally I'd be hunched over this to see it better. So if you see me looking a little bit clumsy, I'm not really seeing what I'm doing. But besides the microphone not being in a good place if I do that, you'd see the top of my gray head instead of what I'm working on, because I'd be bent over on top of the piece. If this were something really critical, amp first, video be damned. But I know I can get good results even if I'm just kind of feeling my way. All right, now, so all the lead-free stuff is off these 4 pads. I'm going to go back with some Custer 6040 and resolder them. And I'm not doing that because it magically will make you sound better. You would not hear any difference in their current state. But it's just a fact that I've observed from repeated repairs on Fender current production amps and other brands, that the lead-free solder that they're using in most production amps these days just is not as mechanically strong as the 6040 leaded stuff, and so this is less likely to crack. I'm going to go back and do the grounds next, and then I'm going to get all this old flux off this, and then I'll show you at that point. Okay, so I've got all the solder reflowed on the input jacks, and I'll go back in just a little bit and clean up that flux, and we'll also clean off this ugly residue kind of stuff from the factory here on these solder joints. Here on the volume pots, I've removed the solder just the same way you saw me remove the solder here. And I'm going to bend these leads over to the board before reflowing solder, just for better mechanical connection. And something I forgot to answer a minute ago, or address a minute ago, is the reason I just don't add fresh leaded solder to the old lead-free solder is that they do not mix, and you get a really nasty gray, grainy solder joint, a lot of times with seemingly air bubbles in it. So I want to get all the lead-free stuff out and start from scratch. So on these input jacks, it's pretty simple. I crimp 2 over in one direction, and I do the middle one the other direction. The only time when I don't do that, as a matter of course, is if there's a trace running real close to them. We can on some models, not an issue here. Just kind of gives additional level of security. The brackets themselves being soldered to the board help because it takes a lot of the stress off because it's bearing the weight here. But there's still the wafer connection to this pot casing can not sometimes over time get a little bit loose. And so that can move, and this just keeps the wafer from wanting to move at all. And it's easily undone down the road if you know what you're doing. And not trying to be aren't I great or anything, but the crucial thing there is I'm not bringing the iron close to the piece, putting solder on the iron, and then painting the joint with solder. I'm bringing the iron to the connection, and then bringing solder into that heated area, and the solder flows over all both the pins of the pins of the pots and the pads and traces of the board at the same time. They're both hot. The solder flows. Everything is good. Now the only other 2 things we're going to change on this, and then we're going to clean everything up, including cleaning the pots, is the slope resistor. Little dinky half watts that, well, Fender says they're half watts. They look like quarter watts. This is a slope resistor. It's got pretty high voltage across it. It has a big role in the sound of the amp. This is a mids resistor on this normal channel. That doesn't really matter. That one's fine. Here's the other slope resistor. And this one doesn't have a mids resistor because it has a mids pot. I'm going to take these 2 out and put in some higher quality 100Ks. So let me get that done. It's just like I showed you in yesterday's videos. Doesn't take long. The new resistors, if you were to buy one of these 100Ks that I use, the Agios, they're like 20 cents each. I think I pay like 5 cents each, if that, for them, because I buy them by the hundreds and sometimes by the thousands. Let me walk over and get the new ones. All right, so here's an actual half-watt carbon film resistor that can handle a 350 volt drop across it. And notice the size difference. When it comes to resistors and power dissipation, and to a degree noise, size does matter. So these may sound slightly better than these, They are much less likely to die than these, because this does have quite a bit of DC voltage across it at its point in the circuit. The plate resistors in the stock Super Reverb reissue are fine. They seem to be 1 watt. So I don't need to change those unless there's a failure. They look all fine. They measure all fine. This is a place that I would want to at least use a hefty 1/2 watt, which is what I've done. And again, in that Princeton video linked that I talked about at the beginning, this stuff is explained. All my rationale for everything I do is explained in that video. So you're getting me before coffee today. So, oh, I already fell out. Great. Well, before adequate coffee. I've only had 2 cups. That counts as before coffee around here. All right, the flux that's on there is not bad, so I don't have to clean it up before I solder. But I'll be going back, like I said, and cleaning up everything. Let's see. Spacing. Just little ones at the end. I have resistor lead benders, but I've learned sometimes, first of all, you do this enough, you can eyeball pretty well. Sometimes just around your thumbnail does a really nice job. Anyway, that's all the soldering we're going to do to this board, unless there's a problem once we hook it all up. So let me put my tools up, and then we're going to be doing some fancy cleaning with isopropyl alcohol and some deoxit and some fader lube. Pretty good for a Wednesday. Or is it Tuesday? It's amp day. I'm not just cleaning where I worked, though I am paying particular attention to that, but like all that yucky flux looking stuff that was on these multi-pin connectors, etc. I'm just kind of do this in sections so I don't have big puddles of alcohol everywhere. Sounds like a bad country song. Big puddles of alcohol. No one steal that. That's my money. And the worst thing of it all. See, I can do that too. Gotta figure out how to talk about a truck in the middle of that. Someone out there is finishing that song or won't be able to get that out of their head. You're welcome. Now, I've not heard this amp. I have no idea whether there's any problem whatsoever with the pots being noisy. But in my experience with these things, they're often a little bit noisy, even from the factory. And given the way it is in the amp, you can't really clean the pots without pulling the board. So I'm just going to give it preemptive cleaning. Nothing too heavy. These pots have this little notch there. That's where you want to put it. I've got this deoxit set to spray very little. Just going to line that up. Just make sure I get this precious fluid in the pot, not just all over the board. Some will always spill and drip. That's fine. That's why we have more alcohol. There's the second verse for you. Just going to rotate that around. I don't expect any of these to need a deep cleaning, but sometimes just to get the new off, it can be beneficial. And I do 3 at a time because there's a working time with these solvents. After a while, they do less. Just rotating all the pots back and forth a few times. they're still nice and stiff. I'm not removing any dielectric grease or anything. Now, if this were a 1959 amplifier or something valuable and vintage, I would not reach for even something as good as deoxit immediately, because on old pots, the deoxit can also actually wash away one of the remaining carbon layers. So with an old valuable amp like that, the first thing I'll do is I'll just move the pot back and forth a few times, see if it's just any dirt or dust that can be knocked loose. And then I'll try very sparing applications of deoxit, followed by fader lube. And occasionally that's not enough, and you gotta get in there and remove the old pot, change it out for one that works, and return the old pot with the amp. But I want that to be because the pot itself was worn out, not because I killed it with too harsh a solvent. But all that said, these are relatively new pots. If they fail from this very light application of deoxit, they were going to fail anyway. That's a faulty pot. In a little while, I'll put a plug into these jacks and give them a little squirt of deoxit on the contacts as well. First thing I'm going to do, I'm going to let all this air dry, which won't take very long. And then once it's dry, I'm going to go back and follow up all my deoxit with everybody's friend F5 fader lube. But I need to let all that alcohol dry off first. So we'll resume soon. All right, as doing the fader lube is exactly the same as doing the deoxit, and putting the panel back in place is exactly the same as you saw in the first video where I took it out. I skipped ahead a bit, brother, and it's all back together, and I powered it up, and the first thing I found out was with the wall voltage at 109, which it was in Memphis today, the bias was set to 25% idle, which is really cold. I used my Variac to bring the wall voltage up to 120, and it was still cold, about 37% idle. And I have adjusted the bias. Now they're at 53% idle, which is where I like to have most Fender black panel amps, AB763 and similar. Good, clean range. Not cold, but as the wall voltage in Memphis will also sometimes exceed 127, I know that the bias is not going to go too cold or too hot. It's going to be just right. The Goldilocks approach. At that point, when I tested the tremolo, it worked just fine, and you'll get a chance to hear it in a moment. But the tremolo, when you turned it off, took like 7 seconds to fade out. And that's because C19 had drifted or whatever. I'm not crazy about that little cap network they have in the reissues. So I took out C19 and I took out R37 and I left R39 in place. It's a 10K. Doesn't really affect anything. Everything still works, but now the tremolo goes on and off instantly, which is a nice place to be. Now I am going to just do a quick little playing test of this to show you, but there's almost no sound coming out of the speaker at all here with the volume off. And later when this is all buttoned up, you'll get a chance to hear it for real. This is a very nice reissue with that kind of rich Corinthian leather, you know, the kind of burgundy Tolex with the wheat grill cloth, and it's got 4 10-inch greenbacks. So this is just a little preview. You'll get a chance to hear the real deal in a real mic'd up playing video.
So like I said, we'll do a real playing test later with it all mic'd up properly. This is just the overhead mic at a distance. Seemed to sound pretty good through the cans. We'll find out when I hear it. But, you know, I'll show with the Strat, and I'll show that even with the decreased cathode bypass caps, it still has tons of low end. It just doesn't have the subsonic sludge that just robs the amp of power. And it's really nice and quiet. And seems very responsive. I think the owner's gonna love it. I have not touched any of the knobs other than the tremolo stuff, and I turned the tremolo off so you could hear it just turn off instantly, which is a nice place to be. So this is not the only amp I'm working on. I'm working on a bunch of amps at once. This is the amp I'm doing videos of, and I'm just kind of spreading it out so there's more stuff on the channel, because I have been very slow to release anything of late, and it's nice to do these things in small, manageable chunks.